right, welcome everyone. We are going to get started now. All right, welcome to the Gather to Grow webinar series. Our topic today is Maíz diversity, understanding the races of corn and their food uses, presented by Luke Moreno. I'm Trina Bizzardi, Program Director here at NAFSA, and I'm delighted to be your host today. Supporting us today in the chat and the Q&A are our other team members, Caitlin Walsh and Maria Blanco. Please feel free to share any questions you have throughout the session in the chat. You may also use the Q&A session. And now I'm pleased to hand things over to Luke Moreno to get us started.
Hello, everyone. Can you guys see me? Yeah, right? Okay.
Yes.
Yeah. Lokanchim Chanyavu, Kachimalia, Enepotiak, Luke Moreno, Enepo, Ueme, Etleo. So hello everyone, my name is Luke Moreno. I'm a traditional Yaqui farmer, seed keeper, and do a lot of traditional cooking. I spent many years of my life growing crops, collecting seeds, and cooking a lot of traditional dishes. And for the last 4 years, I've been studying a lot of archaeology, archaeobotany as passion projects. I traveled a fair amount through Mexico and the US, collecting different seeds, interacting with different seed keepers, seed exchanges. So I've traveled a fair bit amount. So there's still a lot more to see, but I'm thankful for the things I have got to visit, different places I've seen. So I'm the founder of my new intertribal seed organization. It's a collaborative effort where we're dedicated to preserving stories, seeds, and like recipes and things that kind of culminate around southwestern and northwestern Mexican plants and desert adapted varieties. That is called Sakovai seeds. So you guys can find me there through that. We work with a lot of rematriation with seeds too as well. Education for the youth is our goal, is getting kids to learn farming and seed keeping and making sure that seeds stay in the communities and people have an access to those seeds and things like that. I know recently that's been kind of a hard thing, I think, especially with climate change or just industrialization, is keeping some of those older seeds like within our families. So we try to work to make that happen. And also I'd like to thank the NASA team for having me do this webinar. They're super nice, and I want to thank them for the many hours and that they put to helping me put this together with the technical support, the slides, and they're just super nice. So I'm very grateful for that. So I want to thank Mayura and Trina for just all that time and energy that was put into this. All right, so moving on to the next slide, we'll be into the objectives. So our objectives today is understanding kind of a historical and regional journey of corn, some of the different food uses with some of the unique traits, understanding some of the different kinds of corn. And there's a lot, so we're sticking to just the main categories. We're not trying to go too crazy because there's thousands of corns out there, so it's just these are probably the ones that you're most likely to encounter. We're going to be able to identify the different traits. We're going to be going into some history and a little archaeology. And we're going to be mentioning in that journey some of the different historical and regional growing methods in its travels and kind of the ingenuity that was happening, and the different methods. Each climate is different, so it's interesting to see kind of where domestication and where we can really take crops. All right, so we'll go to the next slide. Um, so corn is a very well established study in America and institutions. It's one of our main commercial crops, so it accounts for a portion of our GDP. Um, is government subsidized, which ultimately these things aren't that great due to this. U.S. corn is we're using it for fuel and corn syrup, and it's in pretty much almost all your food now. And famously, you know, um, sprayed with pesticides and stuff. So it's not really a good thing. But through that, the USDA and there's a lot of different institutions that study corn. They do DNA analysis on a lot of different varieties, and um, beside institutional research, there's a lot of earliest 20th century archaeological and archaeobotanists doing studies on corn in like from the early 1900s to pretty much into present. There's vast studies that have been done, and there's thousands of kernels, there's thousands of whole corn ears from archaeological sites spanning from here the Southwest, the eastern states, Mexico, South America. But there's a pretty good archaeological base of corn study here in the Southwest and in Mexico due to drier climates preserving a lot of things pretty well. So um, there's huge amounts of archaeological cobs and stuff that are just stored away in museums or in repositories that you're probably never going to see, just due to it just being a bunch of, I don't know, whoever has access to those things, archaeologists and stuff. Um, so we have a pretty good record of corn itself. The history goes about 11 to 10,000 years in domestication, um, starting from a wild grass. So through these thousands of years, there's pretty good things that were done on sites like carbon dating, where we can kind of get a rough estimate of the progression and domestication of corn, from little primitive grasses to whole corns that, you recognize today. So with all that out of the way, we're going to go to the next slide, which is corn classifications. Here are some of the basic varieties we're going to go into, starting in a starting in a historical chronological order. The first being Teosinte, which you can see on the far left, are just very small, just a couple inches, grass seed heads. We're going to go into popcorn, which I think a lot of you guys recognize is just popcorn. Pod corn, which is a side mutation that led to husks on each individual kernel. As you can see, it's all very husky. Flint corn, flour corn, dent corn, and sweet corn. So over here we have some on the bottom left, kind of some of the descriptions of each, but we'll go into every single one and kind of define it in its own way. Next slide. So the first thing we're going to go into is Teosinte. So this is a wild grass. You can see on the far left that there's the seeds. We have a little seed head. We have Teosinte in the middle as well. Teosinte started in lowland tropical around central Mexico, central to South Mexico, in the modern state that is now known as Michoacan, in the Rio Balsas. Valley. So on the bottom right, we have the Bosses River outline. So you can see this is really the main area that this wild grass, although grows extensively out of this area, the people there were using this as a food source. Um, and that's how domestication begun. And to kind of define it, we have just so we can look at it, we have pointed seeds, it's brown, it's different variations of brown and cream colored tan kind of seeds, very much something like you'd see in the wild. And they are shorter plants, so they're about 3 to 4 feet tall, maybe a little shorter. Um, and basically, what happened was people were needing food sources, which is just wild plants most of the time. They were taking teosinte and they were popping them just like popcorn, actually, and they were eating them, cooking and grinding them in different ways. But through people taking these seeds, they were starting to directly plant them instead of wild growth. They were putting them in soil that was more favorable. They were clearing land to just plant these teosinte grains. And eventually, through that, they started getting a little bigger and bigger, and humans started growing the plants with bigger seeds. And for a few thousand years, you're getting this plant's getting used to human attention. It's getting used to bigger seed heads, which eventually developed a central cob. So if you see in these photos, they're mostly stacked from formation in the way that they're put together. There is no central cob like how corn is now. Um, and then in the middle picture, you can see that there starts to develop a central cob there, and you're starting to get seeds growing in a circular fashion instead of being stacked straight bottom to top. It starts to develop a central cob, and it starts to have rows. So it starts to have 4, 6 rows, and eventually, just with breeding, it gets bigger and bigger. Which the next evolutionary step would be popcorn, which we will get into. But I did want to add a little more and talk a little bit more about some of the history first. And I also wanted to highlight on the top right, we have some teosinte seeds on the bottom, and we have cochiti popcorn on top. And I just wanted to show that even through 10 or 11,000 years from start to finish now, which we have the descendants still growing, you can still see the retention of some of that seed color, the lighter cream, the darker pigment. It's almost the same exact color. And I just wanted to highlight that, you know, corn now, even though very domesticated, sometimes you still have that. It harkens back to some of that ancient beginnings. All right, next slide. So the influence of corn. Um, this is a really interesting thing. So with thousands of years of domestication and people starting to grow corn as it is now, um, it changed a lot of ways that people were living because originally a lot of groups and tribes and villages were on migratory food sources. So with the seasons, you change locations for favored hunting grounds, or maybe you move to different places with different plants that are growing, whether it's you move to the mountains in the winter or you move to the mountains in the summer. Maybe you change completely different areas from coast to inland mountain territories. Pretty much you're kind of chasing a food source. And once corn started being developed and started growing and people started adopting this more, people were able to live sedentary, so they didn't have to move around due to just having a food storage supply or just having a reliable food source that you can grow instead of having to go and hunt or gather. Um, you can grow in the spring and the summer, and then you can store all that corn until the winter. You can stay in the same place and just eat off that corn whatever else you have, maybe that's dried meat or other wild fruits and grains. Um, actually, eventually after corn started getting really successful and there was very bigger varieties, there was more growing. People were growing huge acres of it, a lot. Um, People started to develop bigger cities, villages, things like in central Mexico, you have Tula, um, you have the Incan Empire was largely fueled on corn. Things like Chaco Canyon, Aztec ruins, a lot of these things required you to feed your builders or feed your people that are building this, feed the families or feed soldiers. Um, it led to a lot of building. It led to pretty much a lot of civilization, and you can see this happen as well in Europe and the Middle East with the development of wheat. It changed a lot of ways of living. So the same thing happened here that happens in other continents as well. And the cool thing is that domesticated corn can't grow wild. It requires people to grow it. Um, so it became kind of this symbiotic relationship between people and corn where people were allowed to expand and grow in population, stay in one place, and grow this corn in huge swaths. And it did become this relationship where we help build each other up a bit. So we'll move on to the next slide, and that's river systems. So you see there's a black dot here. That's the Rio Balsas in the modern state of Michoacan. I outlined some dots for each river system and some routes out here. Um, so a lot of corn was growing in tropical areas with a lot of rain, a lot of water. Um, as it started moving up north into deserty areas, maybe we didn't have as much rain or didn't have as much of the climate that corn originated in. A lot of it was being grown through river irrigation. So each of these river systems on the um, west coast, you can see the coastal route. There's a lot of rivers there, and as corn was being traded and moving up, there was a lot of it pretty much being grown with each of those tribes in each of those territorial areas. Um, and it goes pretty far up. So you can see it goes to Gila, Salt River, Utah. Um, some of the planting methods did change as it started getting into drier climates, where they did shift to growing corn and I guess dry farming methods with rain runoff or river valleys, and they were growing varieties that were more harder, older, desert adapted. I think with varying climate and maybe droughts, it stressed out a lot of plants, so they became desert adapted. Um, so there's an interesting thing is there's actually a pretty good continuum of corn from we'll start with a few river systems to the south, like Nayarit, Jalisco, near Michoacan, almost all the way to Utah. Um, but especially more from there to like Salt River, Gila River. And you can just see each of these rivers that are spanning here. It was kind of easy for trade to go up that way. It was easy for river irrigated plants and food travel to go from one river system to the next. So it hopped up each river system. Um, we also have a central route here that will take kind of a while to get into, so we probably won't discuss it that much today. It has its own story. It has its own, journey that it went through the central route. The climate was very different. It might have been grown a different way. And we probably won't get into that today, but we'll focus on some of these other routes. So we'll go to the next slide. So something really cool I wanted to highlight was Hohokam River irrigation. I think some people might not know how extensive it was. Um, Hohokam is in southern Arizona. It's near Phoenix and the Gila River near Tucson. It was a civilization that was there. They're called the Hohokam. And on the bottom right, you can see there's Hohokam irrigation canals. I think there were river irrigation canals that spanned around 12 to 20 miles, and they were huge. They were very huge. They're still being used today, actually, in different areas of Arizona. They still use those old dugout irrigation canals as um, for modern projects, which is kind of crazy. I really suggest you guys go in and look into it because they were able to produce or feed, I think, like 100,000 miles, or no, sorry, 100,000 acres. So with their river systems, they were producing so much. And if you read about some of the records from the early 1900s before they dammed up the Gila River and before we had all this water loss, they were producing excess amount of food, like an insane, like, thousands of pounds of excess food that they were able just to trade or sell. So it was very fertile. It was very well established. They were growing so much. Um, and I also want to highlight we have the Tohono O'odham 60-day corn on the bottom here, which is something that they would have been growing in those times as well. We have the Salt River on the top. So we'll go into the next slide.
Hey Luke, you're on mute.
My bad, I'm sorry about that. So as corn is moving up north to higher elevations around central Arizona is when it starts getting higher and higher. We had shorter seasons. We had to deal with different territory, different like geographical, regional, different differences. So there was a lot more rain in these higher elevation places. Um, so as they got up north, there was adaptation for shorter plants, faster maturity. The frost, like the cold when it gets below 35, comes in faster in higher elevations than it does in lower elevation land. And they started adapting them to rely mostly on rain, having stronger root systems. And you can see that now with the Hopi, with different Pueblo tribes, they have shorter plants that are around 3 to 4 feet when grown up on top of these mesas and things like that. Um, 1 second. And same with Mesa Verde. So we have a picture of Mesa Verde on the top right. In the early days, on top of those mesas, they were dry farming corn. So they had a lot of corn on top. They were shorter plants, around 3 to 4 feet, relied mostly on rain, and they would have been doing some river irrigation as well. But they usually picked different crops for that. And there was a big emphasis on breeding these desert adaptions. So we'll go up to the next slide. This is on starches, right? Okay. So for us to start learning on the taxonomy of this, I wanted to go into starch contents. So we have pop, flint, flour, and flint corn. There's soft starch and hard starch. So if you guys ever tried chewing on a piece of popcorn, I'm sure it could almost break your teeth or chip a tooth or something. It's very hard to chew. And you can see I dissected popcorn on the top left. It's very glassy, it's hard. Compare that to something on the bottom left. We have a flour corn, and you can see all this white starch, which is soft starch. the endosperm is pretty much the inside contents of a corn kernel. So it's either hard or soft. So if you take a look, things like a flour corn you can chew on, it won't break your teeth. They were a lot softer. Um, Give me 1 second. So pretty much we're going into these different kinds. So as corn started getting bigger, a real flint corn is basically a larger popcorn. And you can see on the right, it's bigger, but they have very hard starch as well. So like a popcorn and a flint corn, they share a very hard inner kernel and a hard shell. There was a mutation that happened where a hard endosperm turned into soft starch. And you see that with the bottom here of flour corn, where about 90% of the kernel is soft. The shell is very easy to break with your teeth and things like that. So you have flint flour, which is a mix between flint corn and flour corn, and they're sharing both a softer starch content on the inside and a harder shell on the outside. Basically, genetics from two parents. Each kernel is put side by side, and each one is dissected. All right, on to the next one. So this is counting row diagrams. So basically, what this is a measurement. It helps us trace varieties, lineages with a lot of different varieties and having different row numbers. And we'll be getting into this more as we go on. So these are cross dissections of corn. So you can see they're cut pretty much in half. And then we have the illustrations here. Each kernel on here is a single kernel. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, as we see in the middle. So I hope you guys kind of get like an understanding of how that's counted. You can do that with any corn. You can just grab one right now, and you don't have to see it from a dissected view, but you can just look around the whole kernel and count it. And I'd like to have you guys count how many rows do these two bottom corns have displayed that aren't numbered. So if you guys could put in chat how much kernels you think are in the spiral, just so we can make sure you guys kind of have an understanding of how counting corns go. So someone said 8 in the left, so that's perfect. There's 8 there. And then how much does the one on the right have? Let's see if anyone gets that one. Okay, so someone put 18, someone put 22. Perfect. So it's 22 is the rows. There's a few kernels that are missing. They just broke off, but there would have been kernels in those spots, which would have made it 22. So good job, you guys. I'm glad we got that. So next slide. And then for some examples, which we'll be getting into later, when I said each lineage or each variety has a different row count, generally there's a lot of numbers that are going to be the same across all the different types, but there's generally ones that have more and less. For example, we have on the very bottom, we have flour corns, which are either 8, 10, 12 to 14 rows generally. And I'm using a lot of the higher increments here. Flint flours would be a mix of both of those, which would be 10, 12, 14, and 16 usually. Flint corns are going to be in the higher than that with 14, 16, and 18. The highest row numbers in corn are going to be with popcorns, which will be 16, 18, 20, 22, and 24. Generally, you're not going to see those row numbers in most other corns. They're usually going to be with popcorns due to the fact that they have very small kernels, which creates more of a space for them to develop higher row numbers. If you see on the bottom, a lot of the kernels are larger, creating smaller rows. And a lot of it is just due to how they were bred as well. So we going on to the next slide. So to start off with our corns, after hopefully we get the some of the information out of the way, so I guess you have a little bit of an understanding. The first one is popcorn. So popcorns are the first domesticated corn from Teosinte. So you see on this picture, we have Teosinte on the left. We have our modern popcorns on the right. Through pretty much just growing and domestication, the first corns would have been popcorns. They're small, they have small kernels. They start developing different pigments. So they start having all the colors: red, yellow, blue, purples, pink. Um, so one thing cool about popcorns is that they were very revered ceremonially as well, due to them being some of the first corns. So there's a lot of there's some separation we see here in the Southwest, which I thought was really interesting. Is there's a lot of sacred sites and ceremonial places like caves or different burials and things like that, where they would have been located some ways away from the main village, but they were having offerings of popcorn, or they were bearing with popcorn, or they were doing cave offerings with popcorn, and they were separating those popcorns to be used differently than some of the other larger, more domesticated forms that we know now, which I thought was really interesting. And they're all used ceremonially, but I thought it was really interesting that back then, go back 2,000 years or 1,500 years ago, that you had people putting kind of an emphasis on separating them to be used a little differently. Right next to when they were growing these other varieties, they still had this reverence for it, and they still knew, like, they had this memory of those different lineages, and they're like, these are the first ones, we're using these in a different way. So I thought that was really cool. And like I said before, popcorns have the highest row numbers. So that's 16, 18, 20, 22, and 24. And we'll be going on to the next slide. So as a side note, we're going to touch briefly on podcorn, um, and how this relates in a way. It's not very common today, podcorn. You still see them and they're still around. Um, but a cool thing I wanted to highlight was some of the oldest corn found in New Mexico, in southern New Mexico, near Carlsbad Caverns. So if you guys are familiar with that, there's a lot of caves and cavernous sites in that region. And early early 20th century archaeology that was being done when they were digging up in these caves, you had adjoining caves. One of them was called Bat Cave. So you see in the middle, this is from an archaeological document. Um, some of the first little corns that they found were probably about 3 inches. It's dating back about 4,000 years. So 4,000 years is when they were dating this one. Um, it had these husky, they're called glooms. It's like little papery husks that grow on each kernel, instead of now, you have just a big husk, central husk. It's a really interesting trait. I think people don't know too much about how this came about, but it's assumed that it's some kind of mutation or some kind of divergence that happened in between teosinte and popcorn and podcorn. So it's some of the oldest. Um, so you can see just how interesting it is. It was very primitive. It had a lot of teosinte genetics. It was in the in-between stage of domestication and teosinte just because it's so small. It was very primitive. Um, so I just wanted to highlight that. And it is revered still ceremonially different. And it was archaeologically, also ceremonially placed in different areas. So this was something that was also revered just for its unique traits. In Mexico and here as well, they still revere this corn. Um, in some states in the East Coast, it's called grandfather corn. It's called grandfather corn in acknowledgement to it being some of the first corns or some of the first corns that came out. So it has a lot of story and a lot of history to it. We'll go on the next slide. So now we're on to flint corns. The reason it's called a flint corn is because if you took like a piece of flint and you put it in your mouth, it would probably break your teeth like a rock. So that's where it got its name from. Flint corn. It's very hard, as a hard endosperm, very hard inner starch content. 14 to 18 rows. They generally have higher rows, just like popcorns. A lot of them being mostly just bigger popcorns. They have a glassy and shiny appearance. I'm sure y'all have seen this. I'll move on to the next slide. Flour corns. So we can see here, these are the softer starch ones. We have a Peruvian flour corn called choclo. So this is very common in Peru. We have a central Mexican cacocintle, a northern coastal Mexican flour. So you could find that on the coastal from like Nayarit, Jalisco, Sinaloa, Sonora. We have a Arizona Hopi flour corn, and we have a Tuscarora flour corn on the far right. So these are really good because it basically these genetics introduced a very easy grinding corn. It was very easy just to grind. It's very easy to toast. It was very easy to parch. It made really good flour. It has this great flavor to it. I've tasted a lot of these varieties, and it has a different flavor. Um, so when this genetic mutation was bred, mostly people were growing flint corns and popcorns for a very long time. And after this was developed, these larger kernels, these softer corns, it spread very rapidly throughout this whole continent. So you find these from very South America to Canada now. So we have Canadian tribes that are growing their flour corns. This whole continent pretty much started growing these flour corns, and they're very liked and favored. You still find them today. Hopi and Pueblo tribes, Navajo, everyone pretty much has one of these flour corns. I'm sure a lot of people recognize. Um, so to get into this, there were a couple different, I guess we'll say like dispersal eras of flour corn. So originally there were smaller flour corns that are like 60-day corn from the that you see the Pima growing, and a lot of different tribes in the areas grow that 60-day corn. It's very small, drought tolerant corn. They have smaller kernels, and those were flour corns like that were the first ones that were being grown up here in the Southwest. And eventually there were these larger forms, which we have these pictured here, are these larger forms of flour corn, which have wider kernels. And they generally have 8 rows, 8 to 10 rows was the original row numbers that they carried. Um, it changed a lot of dynamics. So, we have records and carbon dating of a lot of historical and archaeological sites. And we kind of see when these bigger flour corns hit certain areas, there was a lot of expansion. Um, just due to it being more food, these carried more food and it was easier food. And in those days, it meant a lot. So people were able to feed more people, they were able to feed more families, they were able to have larger meals. And we see a lot of expansion happening, population growth in the same timeline as we started seeing these larger cobs show up archaeologically. They were 8 row cobs, and that's a way that one of the reasons why we count rows is, we kind of see a lineage base here. Prior to these 8-row cobs becoming vastly popular, the corns that were grown before were flint corns and popcorns. They were a little smaller. So this new food definitely enlarged the population. It definitely led to a lot of building, and it accounts for a lot of the genetic base and a lot of just the corns that are still grown now. So go on to the next slide. And something cool I wanted to mention with just the ingenuity of breeding corn is you start having different colors. So you start making all these different colors of flour corn. Originally, the first flour corns would have been white, and due to reflection of the inner white starch that was in the endosperm. And people figured out how to add color to that. So people started breeding flint corns or popcorns with their flour corns. So they started breeding blue corns, red corns, pink corns, different things like that into their flour corn base. And they changed the whole color from white to, you can see red, blue, and purple here now. But they still retain the 8-row genetics from the original corn, which is really cool. And they bred out any of the flint genetics that were in there, so it was still very soft starch content, just like a flour corn. It just has a different color. And you can see it's very popular in tribes like Cherokee, Iroquois, Oneida. A lot of East Coast tribes would have different colors of 8-row flour corns, and the same thing in northern Mexican states with the huichol. You can see they have a lot of different 8-row colors of blue. They have red. They have pink. They have yellow. So there was a lot of symmetry that was going on where they wanted their corns to look very similar, kind of like related, and they were breeding this beauty into it, as well as it being a really good food source, because now it was still very easy to grind, it was still very easy to cook, and they just look really pretty now. So we'll go on to the next slide. Flint and flour corns. So this is basically a mix of two parents, which is a flour corn and a flint corn, and you can see a lot of the same row numbers being shared. This is a very common one you find a lot, and you can see in the taxonomy thing we have usually a harder outer shell, and we have some softer starch packets in the middle. Maybe it would be about 50, 40 to 80% soft starch on the inside with a harder outer shell. So I just wanted to highlight that we have these mixes here, along with it also maybe creating new flavors as well. So go to the next slide. Dent corns. Let me make sure. So I'm sure a lot of y'all have seen this. Dent corns are pretty much just corn with indentations in the kernels. So you can see in all these photos, there's these little dots inside the kernels. Generally, what this is they have a harder outer shell and they have a cone-shaped soft starch packet right in the middle. And when there's water loss due to maturing and things like that, it starts to form this indentation. So modern farmers use that to check maturity. So if the cobs have formed this indentation, it's ready for harvest. But with heirloom varieties, I think it's a very interesting subject. I think a lot of this may have come from teosinte influence. So teosinte seeds itself have a little indentation on the tip, and there's a chance of cross contamination. Like when you're growing corn, there's still wild populations of teosinte growing neighboring your fields. So inevitably, pollen from teosinte is going to accidentally get into your field, and that might cause things like these little spiked ends. It might cause indentations. It might change traits, and I think people were starting to breed that into their corn. You see that a lot in the South, in southern Mexican states, where there is still wild populations of teosinte. A lot of their corn tends to look like it has some indentations and some pointed ends. So we'll move on to the next slide from there, which is the heirloom sweet corn. Sweet corn is a really interesting thing. And this is probably what most people would be eating on a daily basis just because you can find this in every store and it's the most common corn out there. You just eat it right off the cob. The origins of sweet corn is a little weird. It's a little dodgy. And that's because it's very perishable. So sweet corn grains don't have a harder outer shell. They don't store very well. So in the archaeological record, they don't preserve. So we don't know too much actually about the origins of sweet corn, but we have a little bit. Basically, what happened is there's a mutation that occurred where the inner starch content of a corn, there's certain genes that got bypassed that led to instead of starch grains being formed, it led to sugars. So there was this all of a sudden there was this mutation that had this very sugary kernel. They shrivel when they're dry. So if you've seen these photos, there's a reason why they're all looking shriveled. These are dried sweet corns. The sweet corns that people are eating now are picked young when there's still water content in it. But if you take out the water content, they shrivel down. It's a very not, a very, they don't have a very good hard outer shell or nothing. So it shrivels down. They deteriorate really fast or they go bad really fast. Rats and things like that will probably end up eating them. Like if they were found. So we don't know exactly when sweet corns are coming up, but it's likely a more recent introduction. So maybe around the 11 or 1200s in the Southwest, I'd say we were probably getting sweet corns. And I displayed here two heirloom sweet corns from the Maricopa, and that's like a Colorado River tribe in Arizona. They would have had some of the older sweet corns that we can look at. They were basically a mix of half sweet, half flour, and a lot of that's due to just local adaptation. It's hard to take tropical plants and grow them in the desert sometimes, so you have to have genetic mixing to have this adaptation. It likely started in southern Mexico or in South America. So we have on the right, we have this ball form of sweet corn, which is likely the original genetic base for sweet corn. This is still grown in Peru and South American states to this day, and it's probably the origin point of sweet corn. So it would have came from a very tropical place as well. Um, I think it's just really interesting that it's a ball. A lot of the modern sweet corn you find now was heavily bred in the 1800s by settlers, where they were breeding for a more completely sweet corn, or the way how you see it now. And most modern corn, sweet corn you find is just very manipulated, GMO, hybridized with like 100 varieties, and um, it's nothing like some of the more original ones. Um, but we'll go on to the next slide here. Before we move on, I don't know if we have time. I want to see if there was any questions that needed to be answered, maybe for a couple minutes.
Yeah, let's ask one question, Maria, if you want to share, and then we'll save the rest for the end of the session.
Yeah, for sure. Let's see. Okay. There was more of a reference, and Al, if you want to clarify, but you mentioned something about, in Michoacan, like the Perpetua people. I'm not sure what you were referencing. If you want to drop that, your question in the chat, and we'll answer it at the end. But the next question, do you know how this goes into ones like the Apache being called the corn people? I've heard some of our creation stories, but would love to hear your view.
Okay, so my view on like corn being in creation stories.
Hmm.
It's in a lot of creation stories, and they all vary differently. So each tribe is gonna tell you a different story. Maybe some in the creation story was yellow corn, some were blue corns, like with Hopi. Um, I can't answer to that completely. I think it's really up for interpretation, and it's been thousands of years, I think, from a lot of things like this, where these things started. And I think in some kind of way, corn was this gift that came up. So for a lot of people, when corn came, it was this really insane new thing. There wasn't a lot of foods that were like this. A lot of the foods we're eating were hunted meat. They were seeds and nuts, like whether it's juniper berries, whether it's acorns, whether it's mesquite pods. It was these very brown, earthy tones, and all of a sudden you're starting to see blues and pinks and whites and yellows. And the only things that can do that are really just flowers. And depending on your region, you might not have a blue flower. So I think for a lot of people, they were starting to see these different colors come up, and it's this very godly thing, and it led to a lot of change. It changed village structures, it changed ways things were being done. So in a way, it changed us as people, and it changed the way we were living. It changed dynamics, it changed politics, and often a lot of the origin stories is you have these gods or you have different deities that are gifting them, and I think it's a really cool thing, and I think it was a very innovative thing to have corn at that point. We nowadays, we have so many different colors. We have Kool-Aid, we have red Kool-Aid, we have blueberries and pies, and you can find any color that you want to eat, but there wasn't really that availability back then. So having colored foods was a very interesting thing. It was a very new thing. You can have these red breads, you can have these blue colors and these yellows, and I think it was a very big thing for a lot of early people in those times to have all this.
Wonderful. Thank you, Luke. Let's move on to the next slide.
All right. So next slide would be popcorn. So obviously there's just popcorn where you just pop it and you eat it with butter. But back then a lot of what they were doing was popping these kernels and they were grinding it for that soft starch flour. I think people, if you try heirloom varieties of popcorn, it kind of tastes different than the commercial varieties that you associate with movie theaters. So you might be like, why would I want to grind movie theater popcorn? But if you get a real good variety and you really grind it down, it has this very nutty, this very soft, this really great flavor. And you have a really small seed that expands into a large flour base that you can make different cakes, you can make drinks, feed your babies, so you don't have to chew on hard seeds. So something I like to highlight is for a lot of Northwest Mexican tribes like Yoeme, Mayo, Tepuan, Pima, Rarumari especially, they like to grind these popcorns for a drink. And in Yoamnoki and Yaki, it's called saktusi. Basically, you're grinding pumpkin seeds, amaranth seeds, popcorn seeds, and runners, and people are drinking this. You're drinking this with water, salt, maybe you have chia in it. But it's a very popular drink, and it unlocks a lot of nutrients. A lot of these old popcorns had a lot of nutrients, a lot of antioxidants. It had different contents that are more nutritious than corns now. So this is very popular with runners, very popular with long distance traveling. Um, so it's a really good way to eat popcorn that was being done. I'll move on to the next slide. To flint corn. A lot of these corns you can use in the same way. So of course, with flint corns, you use it with hominy, tortillas. You started having nixtamalization. So you start adding crushed seashells, hardwood ashes, crushed lime rock, things like that, and you boil that together to remove the harder outer shell, and the water will expand into what you have is like just hominy now. Um, that wasn't really being done too much with popcorns. They were very small. So after kernel size started increasing, you were starting to be able to use it more in different ways. start making tortillas and things like that. If you have a larger popcorn, then you can still make tortillas. And we'll move on to the next one, and that is flour corns, which a lot of it can be used in the same way. They have when you boil a young flour corn, they are very soft, so you can eat them like a young sweet corn, or you can cut the grains off and you can make this really nice pillowy masa to it. Very soft masa, great flavor that you can use for tamales. You can use for tortillas. You can just boil it and eat it like that. So it's it's just had a really wonderful flavor. And we'll move on to the next slide. So Flint flour corn, I think some genetics were being bred for certain things. So having a little bit of like a harder outer shell and a softer inner was good for different things. Like we have Hopi Katoki, which is like these corn nuts. They do a big process and they cook it in this pot over the fire in sand, and they put this salt wash on it, and it really unlocks the inner. It cooks the inside and it opens it a little bit, and it's so good. It's really good, and I wish some of y'all can try it because it tastes so good. It has this great nutty flavor. It unlocks so much flavor from a corn you wouldn't think that is there. And when you combine that with the salt, it's just a perfect snack. Um, it's so good. And you have things like somaviki. This is Hopi somaviki, which is like little tamales, kneel down bread. Um, a lot of times you use blue corn or red corn or things like that, which also had a good nutritious, um, like a good lot of nutrition and a little bit of a nuttier flavor and different texture. They better for a little different texture. So a lot of these things like corn nuts and things like that were being done. And move on to the next. We have dent corn, which is just mostly used for cornbreads. They make good tortilla chips and they make good polenta. They're not very good for tortillas. They're very other things. And like most of the corn now that's being grown is used for animal feed and jet fuel or things like that. But they're also feeding it to us. And so often at the store, you'd see things like yellow corn tortillas, and they're just not very good at all. They're very chalky. They're very hard. It's not a good corn for tortillas. It's not really made for tortillas. Heirloom dent corns are good for tortillas. Modern dent corns aren't. The only thing that they are good for are things like polenta and cornbread, and that's just due to them having this harder shell and a softer inner, a softer, smaller, soft starch um, inside that makes it good for grinding into cooking things like polenta and cornbread. You can't really make a good cornbread with flour corn. You can't really make a good polenta with flour corn. It's too soft. So sometimes you need a little bit of a hardiness to make certain things and do certain recipes. That's a lot that was being done. I think it makes good tortilla chips as well. But and as a side note, I did want to mention a lot of the other corns, like flint corns and things like that. They make good things like dumplings, like corn dumplings. So for some people that know, make these little masa balls, and you put that in soups, or you can get this masa with the water, make it kind of like how you want it, and you can add fruits like blackberries, raspberries, strawberries. Combine it into a little dumpling. You boil that in water. You add maple syrup or whatever honey or whatever kind of sugar you might have. Maybe that's banana yucca, and you can boil that and it makes these little balls of corn masa with fruit on the inside, like berries, and it's really good. It's so good. And things like that were being done for a while. So you take wild berries and you combine them into these little like desserts, or just for savory soups with beans and summer squash and tomatillos and things like that. So we'll get on to, I guess, the question part now.
Yes, hello. Well, thank you, Luke, for your time and your expertise today and all your experience. It was such a beautiful presentation. We'll now transition into the Q&A portion of the webinar. We have a list of questions, and I'm going to hand it over to Maria to read those questions for you, Luke.
All right.
Okay, yes, we have a lot. Okay, so one of the questions is, what's the timing of Western coastal route to Gila River, and about what years did it happen?
So there were constant exchange for thousands of years. So there's different waves. There's initial trade that's going. There's trade that's happening. Sometimes there's trade that's happening more in certain eras. The coastal trade route and even the central trade route would have been happening for a long time. So over 4,000 years. And that's when you start seeing corn hit things like the Tucson Basin, northern Chihuahua, and southern New Mexico is around 4,000 years. They share the same lineage of corn. So there was this uptake from, I guess we'll say, Michoacan or the Rio Balsas that made its way up north and hit southern New Mexico, Tucson, Chihuahua, places like that. Um, Probably before 4,000 years ago. That's just the dating that we have, but it's over 4,000 years. And as time went on, trade routes did get strengthened. So around the 800s was a really big strengthening of trade routes. Around the early ADs was a huge strengthening of trade routes. So there's bursts of trade routes being really strengthened, and it's been happening for the last over 4,000 years. And maybe around 3,000 years ago, 2,000 years ago, we had a pretty big strengthening of that trade route, and you would see more and more. That's how we got things like scarlet macaws, cacao, into Chaco Canyon, and even Utah. There was scarlet macaws, and that's the closest place for a scarlet macaw would have been Nayarit, Mexico, maybe Oaxaca, maybe it came from the Mayan regions. They're still doing studies to figure out where it may have been sourced, but same with cacao. Copper bell Copper iron orgy, like when they were doing smelting, was happening in the far northern place was Nairi, but they were doing it in a lot of other southern states. So you had a lot of these different things. Same with seashells. You have seashells from the coast of California all the way in Utah and Colorado. We have even shells from California or the west coast into the eastern tribes, like near Cahokia and the Great Lakes region. Um, so the trade routes were really vast, and there were certain times where they were really strong.
Cool. Since we're at time, oh my gosh, there's so many questions. And just a reminder, everyone, we have part 2 for squash series coming up. I dropped the link in the chat. So feel free to register and learn more about squash. Corn is obviously a very popular topic, and Luke, you have so much to share.
Mhm.
Let's just end it with, Luke, do you have a favorite corn?
I mean, I'm able to answer more questions if you guys are open for it.
Okay. No
Yeah.
problem. Yeah. Okay. So let's do. I'm just gonna kind of skip a little. First off, yeah, answer what's your favorite corn, and then yeah,
That's
and
a hard
then
question.
I
I don't,
know.
I don't know if I have a favorite chord. I think that's a hard one. I think I have a lot of favorite chords.
Cool. And then I think another question that was pretty important is, can you explain flowery endosperm?
Yeah, so basically it was a mutation where hard starch converted into soft starch. So it became this very soft, grainy insides. And I suggest people go out and like try and chew on a piece of popcorn or something, and or like tear it open. You can see it's very hard if you rub your nail on it. A piece of flour corn you can just kind of break apart with your fingers, or you can drive your nail inside of it, and there's this powder that comes out. And basically that was just bread where it was easy, just an easier and bigger food packet. So I'm guessing in the beginning people must have started seeing that happen and they started breeding for it. So there's already natural soft starch, but it's generally really small. And I think people started breeding the kernels that had a little bit more and a little bit more and a little bit more. So maybe it went from 10, 15, 20, 30, 40, 50 to like 90% soft starch through like, I don't know, thousands of years or however long it took. Um, and they started just breeding for those traits and those genetics where the whole kernel got took over by a softer pillowy inside. Um, does that answer the question?
I'd say so. And then last question. Are dent corns usually harder, more of a flint than a flour?
Generally, dent corns are actually a mix of flour, flint, and other varieties that have like probably Teosinte genetics in it. They're generally harder on the outside. They just have a middle starch they have like a inner pocket, a middle pocket of starch. It's like a cone shape. Um, but they generally have, I think, 60% hard, 60 or 70% hard starch with a little like 30% soft starch in the middle.
Awesome.
All right. Well, thank you so much, Luke, and thank you to the audience for being engaging today with our presenter. Um, Please take a moment to complete our short evaluation survey here. Maria will share this link in the chat once more. But again, Luke, thank you for presenting this today. It's amazing information. Please join us for part 2, Understanding Crop Diversity and Food Uses on April 1st at 10 a.m. Pacific. We hope to see you all there. Again, Luke, do you want to share some last minute words before we close out?
Yeah, just want to say thank you guys. So, well, thank you guys so much for attending. And if you're watching on YouTube, thanks for watching. Feel free to reach out to my contacts. If you want to display that on the screen, my email and different ways you can reach me if you guys have questions. I probably prefer if you guys want to message me on social media with any questions like that. So I just want to say thanks everyone for attending. So thank you.
Yes, thank you. Please complete our survey. And again, thank you, Luke. Have a wonderful day, everyone.